Hari Om. In this session, we discuss a new concept called, or new mathematical procedure called dimensional analysis. Dimensional analysis is a new concept I said. Therefore, we must know what is meant by dimensions of a physical quantity. So first thing is, what is meant by dimensions of a physical quantity? Dimensions of a physical quantity. The definition is, it is the powers to which the fundamental units are raised to obtain the unit of the physical quantity. Okay? The powers to which fundamental units are raised to obtain the unit of the physical quantity. For example, suppose I consider the quantity called force. Whenever we discuss some quantity, the first quantity it's coming to mind is force, because that decides everything. Therefore, the force we measure in Newton. Newton is the unit of force. But Newton as the unit of force is a derived unit, we know. So if you convert that into the fundamental units using mass multiplied by acceleration, that is, this force will be equal to mass into acceleration. Using this we can have mass kilogram meter. Acceleration unit is meter per second square. Therefore, we have the Newton now converts into fundamental form, that is kilogram meter per second square. So, here I have kilogram raised to 1, meter raised to 1, second raised to minus 2. So, these powers are called dimensions of the physical quantity force. Okay? Like this, any physical quantity you consider can be written its unit into the fundamental form, and when you write it in the fundamental form, we'll be having certain powers there for the fundamental units. Those powers are taken to be the dimensions of a physical quantity. Alright? Now, second definition we must know about this is dimensional formula. This is the second thing we want to know. Dimensional formula. What is a dimensional formula? Now I write this thing in a particular fashion, that kilogram represents mass, right? So I take it as capital M, that the unit represents a physical quantity. I am representing it as M raised to 1. Then this is for meter. Meter measures the fundamental quantity, that is length. I represent it as capital L raised to 1. Then second stands for time. I take it as T raised to minus 2, and I put a square bracket here to know that it is related with the dimensions. Now this particular expression, we call it as dimensional formula of force. So then what is dimensional formula? If anyone asks you, you must be able to define it. It's a way of expressing the dimensions. And clearly you can define it like this. It is an expression that tells us which all fundamental units are involved with the what all powers. It is called a dimensional formula. Alright? So by saying that formula, you can identify which all fundamental units are involved and with what all powers. Alright? Now when you write the dimensional formula, remember only fundamental units are involved, and that too you are representing with capital letters. It's only a representation, capital letters, no into or dot anything in between. All these are the things to be known. Now the last definition from this part is dimensional equation. You all know what is an equation is. Expression which is involving an equal sign, we call it as an equation. Now here we can make only an equation like this, that force is equal to m raised to 1, l raised to 1, t raised to minus 2. So dimensional formula of force is equal to. Now this is called dimensional formula. Dimensional equation. Alright. So how to define that dimensional equation? Nothing but the physical quantity equated with its dimensional formula is called a dimensional equation. Alright. So these are the basic definitions involving in the dimensional analysis. Okay.